You know that sound? Yeah, that one. It's like this universal human glitch. We've all been there, ambushed by it at the absolute worst moment. But what if I told you that simple, super annoying sound is actually a ghost in our machine? A really complex biological puzzle with roots that go way, way back in our evolutionary past. Today, we're going to solve that mystery together. So here's our game plan. First, we're going to talk about why this is such a universal annoyance for all of us. Then, we'll put on our lab coats and look at the anatomy of what's actually going on inside your body. After that, we'll meet the neurological masterminds behind the whole operation and explore a truly wild theory about where hiccups came from. And we'll wrap it all up with some practical science on how to hack the hiccup and talk about when this little glitch can become something more serious. All right, let's just start with a simple truth. Everybody gets hiccups. It's like a universal language of annoyance. Doesn't matter who you are, where you're from, your age, you've had this weird involuntary spasm. And get this, it's one of the very first reflexes we ever develop. Scientists have actually seen fetuses hiccuping in the womb. So yeah, it's a biological program that's running before we're even born and pretty much sticks with us for life. I think this quote from The Guardian just nails it. It really is like a hostile takeover of your own body. One second you're talking, you're eating, you're in total control. And the next, hic. You didn't ask for it. You can't really stop it on command. And half the time you have no idea why it even started. And that's what makes it so frustrating, right? But it's also what makes it such a fun biological puzzle for us to solve.
Now, while hiccups can feel totally random, they do have some pretty common triggers. And if you look at this list, you start to see a pattern emerge, don't you? Almost every single one of these involves irritating or stretching out the stomach really fast. Eating a big meal too quickly, chugging a soda, it all points to one thing. Your stomach is sending out a little distress signal. And that's our first big clue. The whole thing seems to start in the gut.
Okay, so we know the trigger is usually something going on with the stomach. So let's follow that signal and look at the actual mechanics of it. When you hiccup, what is physically happening inside your body to create that iconic hic sound?
First, let's get a little technical for a second, just for fun. The proper medical term for hiccups is singultus. It comes from a Latin word, singult, which, and I think this is perfect, basically means to catch one's breath while you're sobbing. I mean, that's a pretty great description for that sharp, gasping quality of a hiccup, right?
So a hiccup is this perfectly, or maybe imperfectly, timed two-step dance. And the speed is just incredible. Step 1, your diaphragm, that's the big muscle under your lungs that controls your breathing, it just spams and violently contracts. That forces a super sharp intake of air. But then, just 35 milliseconds later, that's faster than a blink, step 2 happens. A little flap in your throat called the glottis slams shut. So that hic sound, that's literally the noise of all that incoming air crashing into a door that just got slammed in its face.
Now think about that timing for a second. A spasm and then an instant closure, perfectly synchronized. That's not a random muscle twitch. No way. That's a pre-programmed command. It means there's a very specific electrical circuit being fired off, a reflex. So now, let's meet the nerves that are pulling the strings behind the curtain.
So this little misfiring circuit is called a reflex arc, and you just think of it like a really simple wiring diagram. You've got a sensor that detects a problem, you've got a central processor in the brain that gets the signal, and you've got a motor arm that carries out the action. For hiccups, this little arc is the key to understanding the whole shebang. And here are the two main players in our little drama. First, you've got the vagus nerve. You can think of it as the sensor, or the watchdog. It's this long, wandering nerve that reaches all the way from your brain down to your gut. It's the one that feels that irritation from the spicy food or the fizzy drink and sends an SOS message up to the brain. Then you've got the phrenic nerve. This is the actor. It gets the command from the brain and delivers it straight to the diaphragm, telling it, contract now. And that's what causes that sudden gap.
So where do these two nerves meet up? Well, it's not in the smart, high-level thinking part of your brain. Oh no. This is all happening way down in the basement, in the most ancient, primitive part of your brain, the medulla oblongata. This is your body's autopilot system. It controls all the stuff you don't think about, like breathing and your heartbeat. And this is where that SOS from the vagus nerve gets processed and the contract command gets sent down the phrenic nerve. It's basically hiccup command central.
Okay, so we've got the what and we've got the how. We know the muscles, we know the nerves, but this leads to the biggest question of them all, doesn't it? Why? Why do we have this complex, super specific neural circuit in our bodies that seems to do absolutely nothing useful and just annoys us? Well, this is where we dive into the really strange evolutionary mystery of the hiccup. The honest truth is, nobody knows for sure why we hiccup. But there are three really fascinating theories. The first two are all about early life. Maybe it's the fetus in the womb practicing its breathing muscles. Or maybe it's a clever way for babies to burp out air from their stomachs to make more room for milk. Both of those are plausible. But the third theory? Well, the third theory is the wild one. It suggests the hiccup isn't really a human reflex at all, but an echo from a very, very different kind of ancestor.
Okay, get ready for this because it's pretty cool. The muscle movement of a human hiccup is almost identical to the way a tadpole breathes. A tadpole sucks in water, then slams its glottis shut to force that water over its gills instead of down into its lungs. It's the exact same pattern. But here's the clincher, the absolute smoking gun. You know what stops a tadpole from doing this? The exact same thing that can stop our hiccups, a buildup of carbon dioxide in the blood. This is a massive clue that our hiccup reflex might just be an ancient piece of programming we inherited from our amphibian ancestors. It's the ghost of our inner tadpole.
So, if the hiccup is just a glitchy, ancient reflex, does that mean we can hack the system? Oh, absolutely. Because now that we know all the players, the diaphragm, the glottis, the vagus, and phrenic nerves, we can finally understand why all those bizarre home remedies people swear by can actually work. It's not magic. It's just you hacking your own neurology.
The goal of every single hiccup cure out there is exactly the same. Interrupt that faulty circuit. Just break the cycle. Think of it like being on a phone call with really bad reception and a lot of static. To fix it, you need to send a much louder, clearer signal down the line that just drowns out all that noise. All these remedies are just different ways of shouting at your nerves to tell the brain, hey, pay attention to this new signal, not that old hiccup one. You're essentially forcing a system reboot.
So let's look at how this actually works. Holding your breath? Well, like we learned from the tadpoles, that builds up carbon dioxide in your blood, which directly tells that hiccup center in your brainstem to just chill out. Drinking a glass of water or swallowing a spoonful of sugar? Both of those create a strong, continuous sensation in your throat that stimulates the vagus nerve, basically overriding the hiccup signal. And getting scared? That just triggers a fight or flight response that can jolt your entire nervous system into a reset. See? They all come back to hacking that same circuit.
All right, so here's a technique that's like a combo move in a video game. It hits that reflex arc from a bunch of different angles, all at once. When you plug your ears, you're actually stimulating a tiny branch of the vagus nerve that's in there. When you swallow the water, you're stimulating the main part of the vagus nerve in your throat. And when you hold your breath, you're building up that CO2 to calm the brainstem. It's a triple threat attack designed to just overwhelm and reset the whole hiccup circuit. And here's another great technique, but this one targets the other nerve, the phrenic nerve. So what you do is you breathe in as deep as you possibly can, fill your lungs completely. Then, at the very peak, you keep trying to inhale for about 30 seconds. It feels a little weird, but what you're doing is forcing your diaphragm into a maximum sustained contraction. This sends a powerful, steady hold signal up the phrenic nerve, which basically shouts down that jerky spasm command coming from the hiccup reflex.
Now, for most of us, for almost all of us, hiccups are just a temporary nuisance we can fix with one of these tricks. But what happens when they don't stop? It's rare, but sometimes this simple little glitch can get stuck in a loop, and that's when it transforms from a funny annoyance into a really serious medical concern. Medically speaking, hiccups are classified by how long they last. The kind that you and I usually get, those are called acute hiccups, and they're gone in less than 2 days. But if they keep going for more than 48 hours, they're classified as persistent. And if they last for more than a single month, that's when they become intractable hiccups, which is a very serious medical condition.
And when hiccups become intractable, they are no joke. They're a real health threat. Just imagine trying to eat or drink when your chest is spasming constantly. It can lead to serious weight loss and dehydration. Imagine trying to sleep. The constant jolting can cause extreme exhaustion and mental stress. And, most importantly, sometimes persistent hiccups can be your body's check engine light, signaling that there's a more serious underlying issue with your nervous system or another organ.
So let's just step back for a second and look at the journey we've been on. We started with a simple, silly hic, and we've uncovered this complex two-part spasm controlled by a very precise nerve circuit, managed by the most ancient part of our brain, and with an evolutionary story that might just stretch back millions of years to our amphibian ancestors. It's pretty amazing. It really puts things in perspective, doesn't it? We just dismiss the hiccup as this goofy little glitch, but hiding right underneath the surface, we found this profound story of neurology and anatomy and deep evolutionary history. So that leaves us with one final fascinating question. If a simple hiccup is this complex, what other incredible mysteries are still hiding in plain sight, right now,
inside your own body.